Hey guys, so we were discussing projectile motion. Now, we've been through the basics, and now what we'll do, so we saw that projectile motion acceleration is only downwards, and the vertical direction and acceleration in the horizontal direction is 0. So you get these two sets of equations, and the velocity, the initial components of velocity are given by this. So let's derive an expression for the range of a projectile. Okay. So let's see how can we get the range of a projectile. Okay, and also maximum height. Okay, range of a projectile and maximum height. How do we get these two? Okay. Now let's say that again you have a projectile that's thrown, launched, okay, with some initial velocity v0. And the equations for a projectile, so this is what we want. We want the maximum height, h max, and the range of a projectile. Okay, let's call it R, capital R. Okay, now again, this is for a scenario where the projectile lands at the same y location, at the same vertical position. Okay, now how can we get this? Now, if you remember one important thing, right? We said that the vertical velocity at the top is 0. This condition alone is very useful. Like if you solve problems on projectile motion, this condition is very, very useful. And make sure you remember it, that the vertical velocity at the top is 0, and there's only horizontal velocity. Okay. Now let's use this equation. So let's use this equation: vy squared equals v0 y squared minus 2g delta y. Okay. Now if you plug in vy equals 0, so at h max, vy is equal to 0. Okay, meters per second. Now what you get is you get 0 on this side, so v0 y squared is just 2g, and delta y is h max. Okay, so that's what you get, and you can write this in terms of h max. So you can write, so you get v0 y squared equals 2g h max, and h max is therefore v0 y squared over 2g. So that's your maximum height. So you can see, just knowing the initial velocity, and remember v0 y is v0 sine theta. This is just the initial velocity. Okay. So if you know the initial velocity, v0 y, in other words, you know the magnitude of initial velocity and the angle with which you launch the projectile, you can get the y component, you can get the height. So the height, the maximum height, exclusively depends on the initial vertical velocity. Okay. Now let's look at how to get the range. Now if you use the other equation, so the other equation, so for the range, we've seen this equation: vy equals v0 y minus gt. Now if you plug in vy equals 0 here, okay, it means that you'll get this time, the time that the projectile takes to reach the maximum height. So for vy equals 0, the time will be half the time of the time for half of the journey, right? So you get this, writing it as capital T sub half. So you get 0 equals v0 y minus gt half. So t half is just v0 y over g. So that's also an important equation for the time of the projectile to complete half the journey. So the complete time, the time for the complete journey, is 2 times t half. Okay, So capital T is 2 V naught Y over G. So that's the time for the complete journey. Okay. Now, if you want the range, so this is the time the projectile takes to complete this whole journey. Okay. Now, if you plug in, so we have an x equation. There's only one x equation, right? The one equation for the horizontal location of the projectile. Okay, so that, remember, is delta x equals v naught x t. Now, if you plug in t equals capital T, then you get delta x equals r. So if you plug in the time of the whole journey, then delta x will be this range, right? So, and capital T is 2 v naught y over g. So let's do that. So that's you're plugging that in to the above equation. So you get r equals v naught x capital T. So v naught x v naught. Let's plug in capital T equals this. Capital T is 2 v naught y over g. Okay. So 2 v naught y over g. So you get 2 v naught x v naught y over g. So remember, now we're going to plug in v naught x is v naught cosine theta, v naught y is v naught sine theta, and that's divided by d. So you get 2 v naught squared sine theta cosine theta divided by g. So that's your range. And from trigonometry, you know that 2 sine theta cosine theta is sine 2 theta. So our range is v naught squared sine 2 theta divided by g. So that's your range. Just a side note, you can check that the units are right. So this is meter squared over second squared, and this is meter over second squared. So that gives you just meters on both sides. So sometimes students forget this square. So make sure, if you are confused about whether there's a square or not over here, you can check the units. Okay. So that was the range of the projectile, and you can see the range is maximum. So range is max when sine 2 theta is 1. Assuming that your v naught is fixed. Now you can ask, okay, I have a launcher and it has this velocity. Which angle should I launch at so that I get the maximum range? So this gives you that answer. Sine 2 theta equal 1 means 2 theta is 90 degrees, which means theta equals 45 degrees. So for theta equals 45 degrees, you get the maximum range of the projectile. And before we stop, just to emphasize that this is, again, you can also get this equation by using, you can also get the equation for the range by using this equation also, right? So you can plug in y equals y naught and then solve. You get the time for the whole journey. So you get the same time that we derived over here before. Okay, so you get the same time as this. Okay, so so this is the same vertical location when the projectile comes back to the same vertical location. You can have a scenario where you launch a projectile and the projectile does not come to the same vertical location. So don't use these equations. This is a common mistake that students make. So make sure you don't use these equations for a scenario like this, because it's not the same location. So that's what I tell students. This is like, students get worried that these are derivations. That this is a question that I always get. Do we have to remember this? Well, if you need to know this concept because this is not actually a derivation. This is something you will use when you solve problems, right? So so make sure you don't generalize this formula and learn the technique, because you will extend these techniques to different scenarios, and again, do not use it for this. You solve the whole scenario in a different way by using the same steps that we did, similar steps that we did. So this was it for the range and the maximum height of the projectile. If you have any questions, post them in the comments. Thank you for watching.